Hello everyone, can everyone hear me?
Oh, I can hear you.
How you going? Is that Simon?
Yep.
How you going, mate? Yeah,
Yeah, good.
yeah, good. We should have, let's have a look. We should have Conrad online as well. His microphone's there. Well, I could assume that he's there, obviously. Um, Conrad, can you hear us?
He might turn up.
He's here. I can see him on the list, so that's good to go. Um, all right. Look, so we'll make a start, hey. So look, first of all, let's do some introductions. So my name is Russell Shepherd. I run Evolution EV Up and Electric Car Cafe. Um, Obviously we've got Simon. I can hear you there. Just Simon, let you introduce yourself.
Okay, cool. Hi guys, I'm Simon. I'm from a company in New Zealand called Zero Emission Vehicles. Basically, we've been going for about 10 years or so, and specifically looking at developing technology in the heavy battery electric vehicle space. So sort of a small truck size is what we consider kind of the lower end of what we're looking at. But basically, we've developed a control system that's highly modular and is going to enable things like multi-axles, multi-gearboxes, multi-trailers, multi-battery packs to all be configured onto one vehicle quite easily. So it does work. What we've created does work on a single vehicle, but it's kind of heavily over-engineered and quite expensive to do that. So it is possible, but yeah. So that's kind of where I come from. We've got a vehicle in Australia that's on trial with a mining company, and then it's looking like next year we'll be in Europe, hopefully deploying an 18-ton vehicle on the road there for the European market. So
that's huge.
Quite cool.
Literally, that's huge. That's fantastic. Thanks,
Yeah.
Thanks for that, Simon. And it's great that you joined us tonight, and really appreciate that you've single-handedly made this an international panel. So
No problem.
That's great. That's great. Just as long as you can let us travel there sometime soon, that'd be great. In this Tasman bubble, so we can get out of Australia, that'd be awesome, especially from disease Melbourne. That'd be great. Yeah. Conrad, Gib, EV Talk. Can you hear us? I'm going to go as a no. Conrad? No. Conrad, James.
Hey Russ, how's it going?
Yeah, go. Good. Would you like to introduce yourself?
Sure. Hi, I'm James Pawley, owner of Traction EV, a classic car conversion shop up here in Queensland.
Excellent.
And joining you again for another webinar.
Excellent. And Conrad, I'm going to assume he can hear us. He's jumping in and out. We'll get to him. Conrad runs EV Talk, another classic car conversion shop, consummate professional, and yeah, I'm sure he'll have plenty to say during this call once he gets his microphone fixed. Okay, well, we'll make a start. Just a bit of housekeeping first of all. So obviously, apart from us four, where everyone's muted, there's a chat session button which you can obviously access from the menu. Also, there's a question and answer thingamajig there as well, which we encourage everyone to use. Obviously, everyone's muted because it'd be an absolute nightmare if everyone could talk at the same time. Though we should actually try that one day and see how that goes. And the other thing is, if this presentation is being recorded, so if you miss it or you want to go back and have a look at anything, then by all means you can do, and it'll be posted up probably tomorrow morning once it's all been formatted and what have you. But without further ado, we'll get into it. So I guess the first thing we'll do is cover off this conversion by the Tamworth Tech Shed, and it's it's an interesting conversion to say the least. And just before we get into this, we're going to cover cover off this conversion, and then also we're going to get into I guess there's some questions, and then the safety aspects of working on electric vehicles as well. Is that Conrad?
Hear my audio, and if
I can hear you now,
can
mate.
you hear me now?
Yep, absolutely. Yeah, perfect.
Yeah, sorry, technical issues. Sorry, guys. Yeah, welcome to my second webinar, and I'm ready to jump in.
Cool, excellent. Yeah, so we'll just cover this off. This is a really, I just had a look at this earlier today, and this is a really fascinating conversion. It's a Hi-Lux, as they call it, an i-Lux, which I think is fantastic. I think BMW might have a few words to say about using the usage of but yeah, that's brilliant play on words. Obviously a farm vehicle at some point in the past, it's certainly something that's been well used. Possibly loved, maybe it's not in its past, and then it's being brought back to life and electrified. So I won't try and read that out to you, basically, but I believe the process. This is it's in progress. And what's interesting out of this is they've gone and salvaged 18650 cells. So they've done it really the hard way. To actually get the battery pack together. I guess you all agree it's the easy way. It's the most cost-effective way to do it, but incredibly time-consuming at the same time. So yeah, it's an interesting approach to go. And yeah, it's certainly a vehicle that obviously needs a bit of love, and if it hadn't been converted to electric, or wasn't in the process of being converted to electric, it would have been finished by now, I would reckon.
So much room for battery.
Yeah, no, absolutely.
Yeah, we've done 2 Hi-Luxes like that. So where the fuel tank is, we put a pack there, and where the spare wheel was, we put a pack there, and loaded it up quite well.
Yeah, I think the interesting thing about these commercial vehicles is that, well, certainly with passenger vehicles, we find that if you're going to put in, invariably there's a seating issue. If you put too much weight in the vehicle, then the engineer might turn around and say, well, actually, you can only take 2 people now. You've got to remove the rear seat, either because of, maybe it's because of the fact that you put batteries there now, or because there's so much weight in the car, you can't actually get the 5 seats anymore. But obviously, with a vehicle like this, it's your load carrying capability that actually impacts it. So yeah, so that's the only thing. But yeah, you're right. You're right, guys. It's a heap of space to put batteries in this thing. That's no doubt about it. And again, that engine looks pretty much finished to me. I reckon that's time for that to go. There's nothing much left for that.
Not anchor.
No, that's it. It's finished. It's finished. Yeah, you'll get a few dollars for that. Maybe a beer. So here we go. So here's some questions from the guys that are converting this. So, and we'll take these each in turn. Happy to throw these to the guys, to you guys. So weight distribution, drive setup, and brakes are something we need to think about. I guess that's a question mark. Well, I think that's yes. James, do you want to take that?
Sure, yeah. It's a great idea to weigh any vehicle before you do a conversion. Might be a bit tricky to get this one to a set of scales, but you might be able to find the specs online for the weight of it. And perhaps you could find someone who has a similar vehicle that could get one of these on a set of corner scales and get the weight bias front to rear. And you want to try and better that, or replicate that as best as possible. So you wouldn't want to end up too much weight in the rear and have the front end really light.
No.
So that's something to be mindful of. If you finish the conversion and it ended up being like 50-50 weight bias, or 55
like
front, 45. Yep, that's right.
Yep.
Yeah, if you were like 55 front, 45 rear, then you'd be pretty good. But your engineer might not be too happy if you ended up with 45 front, 55 rear.
Yes. Yes, correct. And look, something we're one of our builds at the moment, we can't actually get the vehicle to a weigh bridge. So we've got digital scales on the end of our actually a forklift. We're using a forklift actually to remove components at the moment. So
Nice.
yeah, so it's great actually. So we've got digital scales. So everything comes. So the engine came out today. So literally, you just put the digital scales on the end of it, and then lift it up and go. There we go. Take a photo, send off the engineer, and you go, yeah, great, happy days. That's exactly how much the engine weighed, and we can just catalog everything as we take it out of the vehicle, which is great.
Yeah, for sure.
So so we covered that weight distribution, drive setup, and brakes. Yeah, you definitely need some brakes.
Yeah, for sure.
So
Disc brakes in the front would be a nice to have. If
yeah,
it doesn't have them already, I'm not sure if that era has discs. I know the later Hilux is a disc front. If it didn't have discs, I'd be looking at that.
What year is it? What year is it?
1856, I think it is. It's pretty old.
It's
It's got to be 70 something, right?
Yeah, I reckon so. I reckon.
It's got vacuum brake already on it, so it must be reasonably modern.
Yes.
I guess it depends also how big the motor is that's going in it. If the motor that's going in it is not that powerful, then, if the total weight of the vehicle hasn't increased that much and the motor's not that powerful, then not a whole lot's changed. So I'm not sure what the process is in Australia, but over here there's a specific test that the vehicle has to pass. And I think it's something along the lines of, speed up to 100 k's an hour and hit the brakes 3 times in a row. And if it passes without brake fade. So I kind of, it sort of depends on how big the motor is that's going in it.
I think if you can do donuts in it, then you got to put disc brakes. I think that's how it works in certain parts of West Melbourne.
If you put disc brakes in it after the fact, you're going to have to get that re-engineered. If you can try and keep things as much as OEM from when it was made and do the same power as you're not going to reinvent the wheel.
That's what we said before. That's the consensus we'll come to previously. These kind of builds is if you're going to go and the quickest route home really is to put a motor in with similar power, but maybe it's heaps more torque, and then you can if the power is broadly the same as the original motor, then you'll be okay, but you still get a performance advantage because you get all that torque from low down, obviously. And I don't know if it's the same in the rest of the country or even in New Zealand, but the engineers just look at the power output of the motor. That's all they care about. They don't actually cover off the torque, which is I think is absolutely fascinating. I think we're doing an EJ Holden at the moment, which I may have mentioned before, but it's woeful. It's just in terms of handling and braking, all that kind of thing. It's drums all around. So for us to even get out of the ground, we're gonna have to do a disc brake upgrade, and it's got no servo assistance, so we're gonna have to do that too, and the list goes on. So there's a fair amount of stuff and things we've got to get through before we can even convert it to electric. So you've got to, I think in this particular case, there's a bit of renovation required, I think, ultimately.
Yeah. Then probably run a vacuum pump for the
yes, absolutely. Yeah, absolutely. Hope we've answered that. I think we did. Do we need a gearbox, or do we connect to the motor directly to the drive shaft? That's that. I think we get that question every time, don't we? I think.
Popular question.
Yeah. Answer is you pretty much always need a gearbox.
And a clutch.
And a clutch. Yeah. So
especially with the ute, if you're going to be throwing things in the back, and if this is around the back of Lismore with all those hills, you're going to want some gear ratios to choose from, climbing the hills and then driving on the freeway. You're just going to need at least a couple of gears to make it drivable nicely.
Yeah, I do agree that having the extra gear or two is a huge benefit to running the factory gearbox. A lot of the other EVs are just single speed, and our Land Cruiser's got high-low range, but it's a little bit difficult to change it. It's not a synchromesh gear set, so it's kind of hard to change on the fly. But definitely I've tested it, and having a low range or having another gear to go into makes the vehicle so much more drivable, especially if it's a ute like this. You get on a big hill or a steep hill, you need the reduction.
Yeah, absolutely. And like in my experience, it is possible. People think there's just heaps of torque and stuff, right? But the truth is that these motors, they can stall if it's too tall a gear.
Yeah.
So yeah, it's imperative that you have a gearbox in between. Having said that, there was a chap whose name escapes me a little while ago, came on. He had an MG midget. I don't know if any of you guys saw it, but he had an absolutely, it was an MG midget. So you know how big those are. They're like, I don't know, 800 kilos or something. And he had a massive 11-inch DC motor in the engine bay. It literally filled. It was that wide. It filled the engine bay from between the chassis rails, left to right. It was just huge, and he just had a direct drive to the diff, and he could do donuts and wheel spins, and the acceleration was mental. So
do 100k.
Oh yeah, that's right. I mean, I think it was limited in terms of how fast it could go, really. But in the performance was, and it was limited, but the performance was, staggering, 0 to 100, and that was it, kind of thing.
Yeah. So just a note for everyone out there thinking about that: all electric motors have a sweet spot. They have an efficiency, rev range, voltage, and amp range. So you always want to try and get within that range, otherwise they're going to get hot, or they're going to be not as efficient, or use more power. So
absolutely. So you can't get away from that. You need a gearbox and you need a clutch, and don't let anyone else tell you otherwise, to be quite frank, because otherwise you're going to be wasting your time. I think we talked about number 3 here. The braking system is something there's something we're not going to. So yeah, okay. In terms of vacuum assisted brakes, Conrad, would you want to take that one? What's your recommendation in terms of?
you jump on eBay, jump on good old eBay, and you get a Holden Astra vacuum pump for about $30 to $40, and you get an airflow vacuum switch.
Yep.
For about the same money, and then it doesn't. I'd run another reservoir anyway.
Yep.
Little aluminium ones. And when you tee those up, put the pump at the end of the circuit, so to speak. So you have your pump hose to your aluminium reservoir, and then to your brake system.
Yeah.
And then they don't cycle, and that's a really cheap system for the DIYs, and it works. I mean, you can go aftermarket, but they're just a lot more expensive.
Yeah,
I see someone put a Bosch one. Yeah, they're nice, but they're dollars.
Yeah, huge, like hundreds and hundreds of dollars. And just the last one, James, do you want to take that one? About the effective motor control and battery systems.
Simple but effective motor controls. Well, you're usually going to get your motor controller matched to whatever motor you choose, unless you're going with like a budget forklift.
Yeah.
Motor, then you might need to look at controller options. I don't have a lot of experience with forklift motor control, but if you're using something like a Netgain Hyper 9, they come with a controller, or a HPVS AC50 or AC75. They come with a controller that's already matched.
Okay. Yeah, like that's the thing. You like the motor controller is for me anyway. It's a key piece of equipment, and it has to be matched with the motor, and there are good ones and bad ones, and HP EVS or Curtis and all like that. They're just absolute quality, infinitely configurable and beautiful to work with.
Especially the Netgain system, the software, the free software that comes with that, the setup is so easy. It's all graphical user interfaces. You just click and drag. The factory settings are great out of the box, but if you want to change braking strength, regen strength, or your throttle curves, it's super easy. Just click and drag. They come with different drive profiles that you can switch on the fly.
Yeah, and also there's a heap of error traps. Certainly with our experience with the Curtis ones, the Curtis controllers, where it'll say, "Hey, you've got this cable around the wrong way, and would you mind changing it for me? That'd be great." Or it's really nice. It's really good error, really excellent error traps, and support, and yeah, they're just excellent. So I wouldn't skimp on that stuff. It's a key, it's instrumental to the success of the build. And then I guess battery systems. I guess I don't know how to ask this question, but I guess it's around which battery systems or which types of battery we would recommend. Conrad, what's your view on batteries at the moment? Where do you think the sweet spot is for this stuff?
I guess James and I both agree. Teslas are still the best bang for buck compactness and capacity.
Yeah.
And again, it comes down to budget.
It is.
Budget is going to be the limit on most things.
Yeah. No, I agree.
So, Teslas are at one end, lifestyles are at the other end, I guess, on the DIY market.
Yeah, Simon, what do you use in your vehicles?
We tend to use the prismatic type block cells. I have done some larger modules that basically some of the battery cell manufacturers offer, but for the smaller vehicles, it's kind of hard to make them fit. So
yes,
the prismatic cells sort of in the 100 amp hour to 150 amp hour range. They're kind of easy to fit around in boxes. So it's, from my perspective, it saves a lot of time us doing that than trying to build battery packs out of, say, 18650s.
Yes.
I don't think I'll ever do that. I might do it for a personal car or something, but in the case, if you get those for free or for very cheap, then it kind of makes sense. Or if you're doing super high production, which is probably something we'll never do. So there is something to be said about the prismatic cells that you just, like a 8mm bolt on the top of them, and you bolt them all together as a pack. So it's like this whole game. It's just a trade-off between, what you can get for cheap or how much time you've got spare or who you have to pay to do what.
Yeah.
I would just say also around the braking, if you guys are running AC motors, then I don't know how much regen you can get off those, like the Warp 9 stuff, but if you've got a little bit more power, but you've also got regen, then there's a bit of braking power that doesn't have to go into the wheel brakes. So
I've managed to get nearly 600 amps out of one of my HP EVS motors.
Yeah.
I actually blew the fuse once on regen.
On regen, yeah. You have to be a little bit careful because on a vehicle like this Hi-Lux, I think it's only 2-wheel drive. It looks like it. If you're driving down a wet road and you've got the regen cranked fully up, and you whip your foot off the throttle, you've got to be careful that the back wheels don't lock up.
Yeah, absolutely. Yeah, especially if you've got tires as good a tread as that, I reckon.
Yeah.
Oh boy. Fun and games. I mean, look, in terms of chargers, look, we use Thunderstruck all day long because they're just excellent, just really good coding and really reliable, and they work with a heap of other stuff as well. Everyone has preferences, but
Thunderstruck's so easy to set up.
It's just great. I love
the manual's big and wordy, but once you start your first setup and you run through the steps that they give you, you realize how little setup it actually takes to get one going.
Yeah. I come from a command line background, Novell NetWare, if anyone knows what that is from back in the day. So all that makes a lot of sense in terms of some people might be a bit kind of perplexed by having a black, white text on a black background like DOS, but I actually quite like it. I like the simplicity of the user interface as it is. But yeah, no, it's great. It's a great product.
And they handle J1772 and
absolutely
CCS2 in the future.
Yeah, absolutely. Yeah, really good, and they're good support as well. yeah, good support. Like it's one of those things. It's not just about. I keep saying this. I had this conversation with a customer the other day, and so I can get this thing for cheap off Alibaba. Go, yeah, sure, go for your life. But if something goes wrong, who are you going to talk to if it fails? And the answer is basically no one in that case. Whereas if you buy a Thunderstruck or a HP EVS or one of those, then you can either get support from the local distributor, like one of us guys, or you can call Thunderstruck up at 3 a.m. in the morning or whatever and get some support that way as well.
And a warranty.
And a warranty, yeah, exactly right. It's just not all about getting stuff for cheap. It's about support and making sure it's going to be fit for purpose and all those kind of things. Yeah. And okay, yeah, he's gone. I love it. I love the branding, and I love the color coordination as well. That's great.
Going full Jehu Garcia.
Yeah, absolutely. That's a heap of work. I mean,
That's a lot of soldering.
Yeah.
Yeah, it is, isn't it?
Do they have a spot welder? That would be a great investment.
You would hope so. You would hope so. See those dials? They're retro, right? Obviously. And then looks like he's doing printed, 3D printed dials as well for it too, which is kind of cool. I think that 200 k's an hour is probably a little bit aspirational, but
Hyper 9 get you there.
Oh, will he will?
You might not be able to stop though.
No,
Yeah.
I don't. Highly unlikely. Highly unlikely. I think it's going to be there forever. No, good stuff. Okay. This is actually Emma Sutcliffe's car. She set fire to her car a few years ago, and this is the remains of it. So I think she put this in here for reference. So another question here about the FEV components. This is we've had this quite a repeated number of times over the last few weeks actually, around putting in upgraded cells into a Mitsubishi Outlander. Who'd like to take that question?
I've done it.
Oh, really? Cool.
Yeah, but I wouldn't do it for anyone else because it's punishing. But I can tell you, you can put 60 ampere pouch cells in the same spot, and we can reprogram the BMU, and that works. So
Brilliant. Cool.
It's too much work to make it commercial.
Yeah. Okay.
Yeah, it's but if a DIY wanted to do it, can be done. And I think Thomas, the Tesla tuner on YouTube, has done a couple of videos on doing it too.
Yeah. Okay.
Yeah, but the BMU is not hard to program if you have a, just your OB2.
Well, the MUT tool.
Yeah, with the MUT. Yeah.
Yeah. Because that's a cheap tool as well, right?
Well,
you can get one of those in super cheap auto.
Yeah, you need level 3 or 4 one. So we also can rehack the BMU to get the range back. So if your FEV is out of warranty, I can trick the BMU to think that the car is only a year old again, because what the FEV does is it doesn't degrade the pack, it degrades how much you can take out of the pack over time. So that's why it goes from 52 down to 42, down to 32. And if you put your watchdog on it, it'll go down to like 27 amp hours.
Yeah.
But you can reprogram that BMU to get you back to 40. But it'll degrade again year by year. So it's something you've got to keep doing.
Yeah, look, I know Graham. I just saw the note from Jamie Lovick there. Yeah, I know Graham from Oz DIY is doing something to an i-miev, yeah, look, it's the same with the. We get quite a lot of inquiries about swapping battery packs over for Nissan Leafs, and it's theoretically possible, but commercially it's not. And like everyone else on this call, we're commercial shops, and it has to be worth our while performing this work. And at the price point, it's just not worth it at the moment. So while it's technically possible, and if someone at home wants to have a crack, then there is a process, and you can go and do some research, and take your car off the road for a couple of weeks while you work it out. But I don't think it's entirely commercially possible. And the battery pack themselves would be, an amount of money, I guess, really as well. Yeah, I mean, James, do you have an opinion on this as well yourself? Is it on your roadmap to start doing these kind of battery upgrades to the older vehicles like the Outlanders and the i-mievs?
No, I do get these inquiries all the time, and I basically give them that exact answer. Yeah, or I say go have a chat with Graham at Oz DIY, because he does do it from time to time, and he can advise people on how to do it.
Yeah. No, absolutely.
I think you'd need a team of guys to make it commercially viable. Just focusing on that, you'd have to have a workshop just doing that.
Yeah, and there's a lot of time burned doing this kind of stuff as well. It's just awful. And there's another one here. Is it possible to program the ECU to allow for higher EV only power? I'm not aware of that. What about yourself, Conrad? Are you aware of that at all?
Yeah, there is a thing you can plug into the OV2, but it doesn't give you more power. It just gives you more, makes it EV only. It's out there on the web.
Yeah. It's was it the FEV something or other?
Yeah.
There's some sort of tool. Yeah.
We've got 100 kilowatts out of one on CAN bus control, but I would recommend it because when OEMs manufacture a motor to do 60 kilowatts or 70 kilowatts all day long, that's what it will do. The moment you start putting 100 kilowatts through it, it's not going to do it all day long.
Yeah.
I think I said on the last webinar, probably next year we'll have a commercial viable system for the FEV. And since they're pretty cheap motors, and if you put them in small cars, it'll be...
Yeah, it'd be great. Yeah. I think that's the route forward for a lot of we're aware of a number of conversions that are happening now with leaf components, and that's potentially the way forward for a lot of DIYs, and potentially even professional conversion shops like us, in terms of relatively easy to do and relatively easy to get hold of, but you're still not saving that much money compared to a brand spanking new Hyper 9 or AC51. It's not $50, it's still a lot of money, still thousands of dollars, so you can't really get away from it, unfortunately. But yeah, no, it's an interesting question. Having higher EV only power, that'd be great. And it's interesting that I think obviously they're capable of it. It's just the coding's a bit harder, I guess. Okay. I think we covered that off in the previous slide. Aftermarket, I think you touched on this as well. So this is very, very technical, mate. Conrad, are you able to answer this question here?
Yeah. So even though the IGBTs are rated at that, doesn't mean the wiring's rated. The wiring inside that control is rated for, which I'm pretty sure it's not.
Yes.
So you do the math. So 390 kilowatts divided by, it's over 1,000 amps, and there's no way anything inside that controller's got a 50 mil cable in it.
No, that's right. And there's also it looks high. It looks like a high voltage. It's a high voltage system, so 300 or 400 volts or whatever it is, in one of those things. And the truth is that all the connectors elsewhere, you're right, are just not anywhere near that. They couldn't possibly handle it. So ultimately, if you want 390 kilowatts, then
come and see me for a Tesla motor.
Yeah, I was going to say that. I was going to say go and see the Conrad and look after you. Yeah, there's easier ways of doing it and more reliable ways of doing it as well. I would imagine too. Another burnt car. Okay, cool. I'm seeing a theme here. I'm seeing the theme. Okay, excellent.
We're heading somewhere.
Okay, safety. And I put something on the on our socials earlier. If you want to find out, if you want to find out how not to hurt yourself or set fire to your car, join the webinar tonight. And when I first put it in, I forgot to put the word "not" in there, so it actually reads, "If you want to find out how to set fire to your car and hurt yourself, join the webinar tonight." So, yeah, luckily I managed to catch that before I actually click send.
So we've got all the thrill seekers here tonight, then.
Yeah. That's right. So, I guess, Simon, do you want to take this, because you're probably closer to this than we are in terms of the crash worthiness. You've gone through this full type approval for your vehicles, right?
Yeah, sure. So we have quite a substantial battery box in the front of our Land Cruisers where the diesel V8 used to be. It's a similar sort of weight and a similar sort of size, and a similar sort of not compressibleness. So given the way that the factory motor was designed to kind of go into the trans tunnel, and the engine mounts hold it down, and the cups on the engine mounts sort of lock it all in, and in a crash it all sort of disappears into the trans tunnel, which is where it was designed to. So we've used the factory engine mounts on the bottom of the battery box because of the way that the cup sort of grabs on and holds onto the battery box. So there's kind of two factors. What actually physically happens in a crash. So it has to have physical integrity, as in some sort of box that can handle a decent amount of impact. But also there's the electrical part of the crash as well. So this is where your multiple fusing points come in. So there is also, in the New Zealand standard, provision for a crash sensor, which we fit. So if there is an impact, it throws the contactors open, so the pack will be open circuit anyway. But then it basically comes down to mechanical stuff. So for crashes, our vehicle is actually not so much for crashing, but this is our corrosion protection partly. We've actually got all of our cables in a stainless steel duct that connect all the battery packs together. So that goes a certain way to stop cables getting severed in the event of a crash. Also, we use multiple fusing points. We have a fusing point at one end of the vehicle and two at the front. So if the pack does, for some reason, you're in a pretty huge crash, you've still got fuses at one end of the vehicle and at the other. So it's one of those things definitely that should be considered. Obviously the batteries need to be held down, and also the inside part, like the lids of your battery boxes, need to be made out of something not conductive. If the car goes over on its roof, or you have go over a big enough jump somehow.
Sounds like you've tested it, Simon.
I haven't, but the guys on site test it.
Okay. Excellent.
Yeah, so there's just things to be aware of, and you can just put a bit of. I like to use the electrical switchboard stuff that you'll see in residential houses that's rated for high voltage and also fire. So that's a good thing to put on the underside of battery boxes. Yeah,
nice. I know that sounds all very familiar, actually. I know with the conversions that we've done when we talk to our engineer, he, especially with front wheel drive cars, he wants to see the mass pretty much going back into the same place as it came out of, really. So that, if it's gets a hit from the front or the side, then, and if the battery boxes are mounted to the same place as the engine was originally, then it kind of should behave in the same way and should go in the same direction. So if all the crash testing was done back in the day, should still be relevant, I guess, to a certain
Yeah.
extent.
If battery boxes are, I definitely don't like to put them in the cabin, but some cars, you know, wagons and hatchbacks sort of things, they do end up being sort of around that area behind the driver or behind the passengers. So if they are behind and not outside the cab, like in a Hi-Lux chassis or something, they definitely need to be held down real good, because in an impact they will come forwards.
Yeah, absolutely. And look, I don't like doing that just from a point of view. It's just not very neat, you know. It's just it's all very you know, DeLorean from Back to the Future. If you you know, if you've got a whole lot of, you know, a flux capacitor right on your shoulder kind of thing, or battery box, same difference. It's not a great look, in my opinion. But you know, each their own, I guess, really.
If you've ever got questions about how to mount your battery boxes, if you're unsure, talk to your engineer who you are speaking with about your conversion.
Who you've already spoken to before you start the project, right?
Yeah, that's right.
Yeah,
Battery
exactly.
boxes are supposed to be 2G front and rear and 1.5G on the sides. So
20.
Yeah, 20.
20.
20
Multiplied by 10, mate.
What's front and rear?
Well, front is 20. I forget what it is left and right and rear, but it's 20G front.
So if you've got a 200 kilo battery box in the front,
yeah,
it's got to be, the hold down bolts have got to be 20 ton rated.
correct.
Yeah.
So, look, I think it's one of the misconceptions when we get, you know, customers ringing us and saying, you know, can you give me a quote for converting a car? And we go, well, you know, we've not done one of those before, so we've got to engineer it to withstand all of these forces and all that kind of stuff. And then, you know, that's why it costs more than $5 to do that work, because we've got to work. It's got to be fully engineered to make it, you know, compliant. We're not just, you know, putting a picture frame up. We're doing a bit more than that. So it's going to perform as expected in the event of the worst. Yeah, and look, the fail-safe measures as well. That was really well covered, actually, Simon. Really, and it's nice to really great to hear all those fail-safe systems you got in there. I mean, from an Australian standpoint, you only need to have one point of failure, if you know what I mean, or and in the I think it's
Your inertia switch.
Yeah, inertia switch. Yeah. So it's just one inertia switch, but I really like what you've done there in terms of having multiple failure points in the event of accident.
This is a new pack too. It does say that you should have fuses.
Yeah, that's what OEMs do, and that's what essentially you are now as well. So yeah, that sounds really that sounds great. That's a really good way to go about it for sure. But yeah, someone I think
failure.
Say again, sorry.
Just on that question there, that last question about the electrical throttle failure. If this was in a conversion and you had a manual gearbox, you know, first thing you do would be clutch in, neutral.
Yes.
But your key switch would be your next go-to. That should kill all power to the motor. Your key switch should be killing a relay, which is killing a contactor, which is killing your high voltage pack. So
yes,
you know.
Yeah, absolutely.
And the other thing too, if it is on this motor control, like all our throttles, we put in a dual Hall effect for that reason. So if one plays up, it will shut down. So it's got to have both Hall effects on the throttle being equal.
Yeah.
But they mean more at the controller.
Yeah, exactly. So look, you're right, and it's the throttle failure commanding the motor. Yeah, look, there's lots of fail safes would be in place. Like you say, you got the inertia switch. You've got multiple inertia switches. You've got take your foot off the gas, put your foot on the clutch on, turn it off, and away you go.
Or even have your forward reverse neutral switches, put it into neutral so that
correct.
What you can do on the Hyper 9s as well, anyway. So
exactly. So that's all the schedule questions. We've got a couple in the in the text here. So Jamie Lewick, hi Jamie, how are you going? So his question is, I know there's a lot of people who do transverse engine conversions just mount to the original gearbox. Why don't we or people in general use Nissan Leaf or Outlander conversions, drivetrains, and just drop them straight in? Who would like to take that one?
I can give it a shot.
Sure.
I guess with using all this stuff out of OEM vehicles, it's not just take a motor out and put it in as you would do, say, in an older internal combustion engine vehicle. There's a whole lot of stuff that has to be hooked up to it to make it work. And, even to get a motor to activate and become in the state where it can even turn, you might need to have all of the battery stuff, all the BMS stuff hooked up, all of the cabin controls, the ignition key, all the security stuff. I know for some vehicles, some of the Toyota stuff that I've done in the past, even to get the motor to fire the injectors, you've got to have the ignition barrel, you've got to have the right key, you've got to have the door locks, all the immobilizer stuff. So it's not as easy as just sticking a motor in. So there are people, you guys might know a bit more about this than what I do, but there are people on YouTube and that who are designing their own circuit boards and controllers specifically for making it easier to use these vehicles. I know the Nissan Leaf ones are pretty common, and basically they just hack into and bypass all of that control stuff and control the motor directly, which is quite a nice solution. So basically you have to wait for anyone to do that before you can start using the stuff, unless you want to try and do it yourself. But if you want to try and do it yourself, you'll need a pretty solid background in sort of embedded software or embedded programming and hardware. So basically,
and if it goes wrong, you need support. You've got to, wait for that person who's done that work in his bedroom or whatever it is to fix it.
So there needs to be, for someone to do it commercially, there needs to be a market. Otherwise, they're just investing money into something that they'll never get a return on, which is not going to happen. So either wait for someone to get so excited about it themselves that they want to do it in their own time, or choose another option. Like the Tesla stuff seems to be pretty well supported, and for good reason. It's kind of the best. So
Jamie's just put an addendum there. He was thinking more for the mechanical side. I'm happy to take that, unless one of you guys wants to.
I can. With our Tesla stuff, we have output shafts now for 930 Porsches, so that fits all the Volkswagen 911s, 968s, 912, and that's all bolt-in with the our factory-mounted system. So that'll bolt into all those vehicles, into the original engine mount points and straight into the drive shafts.
And I guess in our experience, when you're connecting the motor up to if you're putting like an AC50 or 51 or whatever up to a factory gearbox, it's kind of a well-trodden path. And whereas if you're trying to put I think they call it a K-frame from another vehicle into the K-frame into a different vehicle, then there's a whole lot of other considerations and mechanical challenges around that, and you got to work out where you're going to mount everything, and that becomes a whole lot harder, unless it's it's a proper, like Conrad was saying, it's a rear wheel drive motor, and it's really easy to mount them all up and everything. Front wheel drive vehicles are just I feel like don't lend themselves to that kind of stuff. I don't think. What do you think, James? Do you agree?
Yeah, definitely. If you were going to put a Nissan Leaf drive unit into, say, an older Honda Civic or something like that, you're also choosing a motor system that runs on near 400 volts. So you're going to have that safety factor involved. So it's probably not suggested that you do that for your first conversion. And you've got to consider how to build that pack that's going to be up at 400 volts and still give you the range that you need as well.
Yeah, look, that brings us. I mean, we should have been talking about this earlier in the session as well. But that's the other thing that we don't really talk about too much is the safety aspect of these things. That if you're building a car which is, 350, well, 300 volts plus, it's not like you're just making one connection and you're done and you're walking away from it. It's when you build the pack, it's 300 plus volts for the entire time you're working on it, and all all the risks that are associated with that, and you don't really come back from a zap from 300 or 400 volts. You just don't. Whereas if you
and 175 is a lot kinda.
Yeah.
People died from it though. People have died.
Yes.
Anything over 72 volts can be deadly to the right people.
Oh yeah.
Yeah.
So,
Exactly.
The bottom line is that, to me personally, I don't think it matters whether it's 400 volts or 100 volts. It should still command the same respect.
Absolutely, and the challenge that I've got, or the struggle I've got with a lot of the time, obviously, I see a lot of stuff that goes on Facebook where people are giving advice when they have no business to. I struggle with that, and also, they're giving advice having not completed a conversion themselves, having no formal training or experience, and it's pretty scary when you see those kind of things in public forums. Sure, and we had a customer today actually asking for a quote for some equipment. He said, "Oh, I can do it. It's no issue. It's not a big deal." And you go, "Well, what's your experience?" "Oh, I'm a project manager." I said, "Well, yeah, but that doesn't really give you the skills to convert something from scratch and deal with all the high voltage considerations. There's a whole design behind it to make sure it's safe, not just during the build, but once it's completed as well."
One of the other things you mentioned, design, that's pretty critical for safety is just design the battery pack in a way that is easy to work on. It's quite logical when you look at it, and it's just keep things kind of simple and easy to work on. When you're sort of in weird positions, trying to lean under things and with your hand go upside down into places you can't see, that's where things get a little bit, that's where the risks kind of creep in. So that's definitely one thing, is make things easy to work on. If you can, have things so you can pre-assemble them outside of the vehicle and then drop them in.
Yeah.
It does make things a lot easier and a lot safer.
Yeah, absolutely. Obviously, plastic tools, all that kind of thing is really important. And the technique we use is we always work with the packs in halves, or in thirds or quarters, so it reduces the voltage right down. So if there is a mishap, then it's less of a mishap.
Yeah, and if you've got cables coming out of a box or exposed terminals, try and avoid having them close to each other. If it means you have to run an extra cable somewhere just so that you can take the cable out the other side of the battery pack, it means it's a lot harder to accidentally touch them. Yeah,
absolutely. And the other thing is that a lot of customers don't realize, and general public as well, it's not just about electrocution, it's actually the heat. We know of a number of examples where a spanner or a tool has shorted out two terminals, and it's been relatively low voltage, but the tool has actually glowed red from the current going through, and it's burned. Actually, there's been burnage.
They've grabbed it.
Yeah, exactly. Grab it.
That can happen on a 24-volt truck battery. You're doing up a terminal and you accidentally touch it on the chassis, and then suddenly your 13 mil spanner's got no ends on it anymore.
Yeah, exactly. So imagine doing that with 300 volts, and
Yeah.
something's capable of delivering a heap of amperage. Then absolutely. Jamie again just asked a question: do you feel there should be training and guidance be provided, including the use of PPE? What do we think, guys?
Working on it.
Yeah.
Yeah,
Yeah.
it's coming, Jamie. We're pulling this together at the moment because the answer is yes. There needs to be training. And guidance and Jamie, I'm pretty sure you're aware as well as I am of people providing advice on Facebook forums, all that kind of stuff when they have no business to. I think that needs to be nipped in the bud as well, because that's pretty dangerous. Not just on the charge, not just on the conversion, but the charging side of things. Obviously, our business evolution is on the charging side, and we've had lots of people, provide advice along the lines of, "Hey, you can just plug." Even the point where I saw someone on a Facebook forum suggesting that you just ground down a 15 amp plug so you can plug it into a 10 amp, and you just go, well, no, you don't do that, right? That's not really the thing to be doing. Anyway, we digress. Another good question from Jamie, in regards to converting more modern cars, what is the comfort level of tackling CAN communication to get the vehicle behaving as when it had an ICE engine? Who would like to answer that?
And give that one a shot. So we have done a conversion for a company in Australia called Autoline for mining in the underground mining industry, and their favorite vehicle was the Toyota Land Cruiser, and they just buy them new. So the conversion that we did was at the time it would have been a 2018, I think, Toyota Land Cruiser. So there's definitely a lot of stuff. We use the original gauge set. So the gauge cluster, we just put an overlay on it. So, we use the RPM gauges, the battery gauge, and all the warning lights and stuff all still work. And that was quite a significant hacking basically into the Toyota CAN bus system. And it kind of is only feasible to do this sort of stuff if there's a market there and there's future sales. So the good thing about software is that there's a lot of time and resource that you have to tip into it at the start to develop it. But after the second one, it's kind of free. So that's one of the reasons we spent the time and effort to do that. But just be aware that software development can lead on and be extremely expensive. So if you can avoid, it depends totally on your level and your comfort level of understanding the CAN bus communication protocol and giving it a go yourself. It's definitely something that you could teach yourself, especially if you were a software engineer. If you're not a software engineer, I would say you kind of just keep an eye on what everyone else is doing. Eventually, there's going to be, these electric motors will be coming out of vehicles, and they'll be basically worth scrap value if nobody can find a purpose for them. So eventually, I think people will come up with solutions to make, easy plug-in. Here's a kit to make a Nissan Leaf motor work. And I think even for Nissan Leaf stuff, or especially the Teslas, you can already get that. But it's these sort of, Toyota or Lexus have got this nice integrated 6 or 7 or 8 or something speed transmission with quite a powerful motor in it, but you kind of can't do anything with it until somebody wants to invest in figuring out the software and the CAN communication. So
I think for me the constant challenge with this stuff is that we're converting the vehicles. It requires a high level of skill, and not just from the CAN bus but in general, and it requires a high level of investment in the technology, and there has to be a return. And similar to what we talked about before about the Outlander and the i-miev and all that kind of stuff, and the battery packs and all that kind of thing. While it's possible, it's
not viable for a one-off.
It's not viable, and we try and be polite when people ring us up and say, hey, how much would it cost to put a 62 kilowatt hour battery in my my leaf that's only worth 10k.
Yeah.
Yeah, and then when you tell them it's going to be like 30k to do it because we've got to buy the battery and we're going to pay someone to do it and all of that kind of stuff, then it's a really, normally it's a fairly short conversation. But that's where it's the same thing with all of this repurposing of.
Yeah, no, Simon's right. So we've just hacked the Model 3 and got it commercial. But there is probably a year and a half of research and development in that.
Yeah.
And to make it a commercial warrantable board is a lot of work. It's like our CCS2 charging protocol that we have now. You know, it's still £5,000. And people go, oh, why so expensive? Well, because the guy that's come up with that system,
he's given up a lot of his time.
He did a year of doing nothing else but working on that, and to make it work with Orion, Ziva, BMS, and a couple of other systems. It all takes time.
Yeah, it does. It does.
But they will get cheaper. You know, in a year they might only be £1,000, but they are not going to be £1,000 at the start, just like anything else.
And then you've got the chassis itself with all of its onboard CAN bus as well. So if you want to integrate that Tesla drive into a 2017 Nissan GTR or something cool like that, you've then also got to hack all of the body controls.
Yeah.
That
and you literally have to hack it if you're the first person. You don't get this information from, say, Toyota. They definitely don't give this out freely.
All proprietary.
Yeah, but by the same token, you can buy a CAN sniffer now, 10 times cheaper than what it was a year ago. So
yeah,
a CAN sniffer is a great tool. It is awesome if you're into reading CAN messages, and you can sort of sniff a sensor box, and you know what it needs to stay happy, and you can replicate that with a bit of Arduino software. It's not too hard, but
yeah, look, like anything, look from our point of view, it's like any business. There's got to be a business justification to investing time in it, and we have to, just like everyone else on the call, you've got to justify green lighting a project to spend a year developing something to make it work. So that's why I guess with all of our businesses, we either convert classics or we convert commercials, because that's where the revenue is. Whereas someone with a 1993 Toyota Camry, not so much.
And you got to make it. You got to tick a few boxes, not just commercial. You got to go. What was the ice motor like? Was it crack? Well, if it was crack and the car's going to retain value, then you can.
Yeah. Just got one more question before we wrap it up. Is it difficult to get a newer car converted? I'm thinking about stability control. That's from Francisco.
Stability control is probably the most complex part, I would say. It's kind of funny, these Land Cruisers that we work on have got still bench sort of bench seats and manual wind up windows and stuff, but still they have all the full emission stuff and all the stability control for the Australian market. So while they're quite simple when you look at them, under the hood they're actually extremely complex. So the ABS controllers and the stability controllers and this kind of thing, that's sort of another level above just general body CAN bus stuff. Tends to be a lot quicker, and you have to. You're definitely going in there blind. You kind of just start. You need to just start. You just got to spend a lot of time on it, and you have to try stuff, and you kind of risk things breaking. But that's just part of the game, I guess. You do it in a safe way. Do it in a safe way.
Yeah, absolutely. In answer to Francisco, yes, it's difficult.
Yeah,
avoid.
And a lot of newer cars now with the power steering units, electric power steering units, they CAN bus control and link to the
exactly.
motor output and speed.
Everything connected to everything. So we've got we've got. I can't tell you what it is, but there's a new car being delivered to us in the next couple of weeks. It's brand. This literally the customer's going to buy it from the forecourt, and then drop it off to us, and then we're going to tear it apart and start again, and put an electric motor in it. So it'll have done maybe 10 Ks. If
What is it?
I can't say, but it's not
Is it 4-wheel drive or 2-wheel drive?
I can't say. Anyway, it's but it's but yeah, so it'll have done less than 10 Ks, and we'll have to pull the engine out, and away we go. So one of the big challenges is going to be, well, stability control, right? We'll have to get into it. So it'd be pretty. It's one of the biggest challenges. It's mechanically side. It's going to be, relatively straightforward. Nothing we haven't done before. But from the electrical perspective, it's going to be right up there.
Yeah, it's going to be interesting to try.
And I can't wait. It's going to be great. It's going to be
talk
great.
to the electric motor to slow down with the stability control and torque control.
Yeah, exactly.
I know Hyper-9 does that a little bit, but whether or not it's good challenge.
Yeah, no, looking forward to it. All right, I think we're done. Look, thanks guys so much. That's been really enjoyable. I don't know about you, but I've had a beer. Well, I've actually had a couple of beers while we talking. So I should have mentioned that. This tonight's sponsored by King River Brewing. Anyway, thanks all for joining us, guys. Really appreciate that. It's been really enjoyable and interesting. Hope everyone else has enjoyed it as well. The recording will be posted up tomorrow morning, and we'll send links to everyone who's joined as well. So have a check in your email. If you need any support, or you're looking for a kit, or you're looking for someone to convert your vehicle drive in, drive out, then by all means have a chat with any of the guys that are on the page right now. Electric Car Cafe, Traction EV, EV Talk, EV Classic, Charge Garage, or ZEV NZ. But yeah, thanks very much indeed for joining us, and we'll do it again next time, Tuesday 10th of November. Thanks guys. Thanks.
No problem.
Is
See you later.
Thank you. Bye.